Matrices are a very useful tool for the engineer, but sometimes we have to get a bit tricky with them. And one of the things that we need to do sometimes is find the inverse of the matrix. So if this is the matrix A, or matrix A inverse, how do we work out the inverse of A? And first of all, we're going to use Gauss-Jordan elimination. Now, Gauss-Jordan elimination is similar to Gaussian, but we take it one step further. So first of all, we set this up as an array. Notice we're using, and on this side, we're going to put a line there. This is not a closing of brackets. We're going to set up what we call an identity matrix. An identity matrix is basically a matrix of what is however many, where there's a diagonal line of ones running through there and everything else is zeros. And what we're going to do is we're going to do a series of steps using Gaussian elimination. And so we're going to turn this side into the identity matrix. But we're going to use the principle, if we count this as one big equation, what we do to this side, we also do to this side. And what that means is when this side looks like the identity matrix, so when this looks like that, this side will be the inverse. So let's actually try and apply this. So hopefully you're familiar with the rules and confident with the rules of the Gaussian operations. So here's my matrix. And I want to turn this into an identity matrix. So I want a 1 there, 1 there, 1 there, and everything else is zeros. So the first thing I'm going to do is turn that into a 0. So I'm going, again, I call this A, B, C. I know other people call them 1, 2, 3, but I prefer, it's just me. You can call them whatever you like. You can call them Tom, Dick, and Harry if you want. But what I'm going to do is in this row here, I'm going to go first row, minus A minus C. And as I was saying before, it doesn't really matter if you want to do it the other way. You can go, this row can be C minus A, but mathematically it will come out the same. So I'm not touching the first row, 2, 1. So that's staying the same. I'm not touching the second row, 3, 2, 1. But the third row is going to be A minus C, so 2 minus 2 is 0. 1 minus 1 is 0. 2 minus 1 is 1. And again, I must carry on, because what you do to one side of the equation, you must do to the other side of the equation. So this now becomes 1 minus 0 is 1. 0 minus 0 is 0. This becomes 0 minus 1. So this now becomes negative 1. And the reason I subtracted C from A was to just make that easier, left that as a positive number. Remember, usually if you're doing basic arithmetic, if I were to go C minus A, I'd just end up with that as a negative number. Don't worry. Have a play. But the big important thing is here, I now have a 1 down here and I have 2 zeros. I now want a 0 and a 1 there. So I'm now going to investigate how to do that. The easiest way here, well, I might want to get, how would I do this? I want to get a 1 on the top. So the easiest way for me to do that, with my way of thinking, is to go row B, because that's got a 3, minus row A, because 3 minus 2 is going to give me 1. So I'll do that. Now, it doesn't seem obvious, but so row A is now B. Remember, this is row A, B, C. So 3 minus 2 is 1. Row B minus A is 2 minus 1 is 1. Row 1 minus 2 is minus 1. And I must do it on this side as well. So 0 minus 1 now becomes minus 1. 1 minus 0 becomes 1. 0 minus 0 minus 0. And as I only did it to row 1, all of the other stuff is going to remain the same. 3, 2, 1, 0, 1, 0, 0, 0, 1, 1, 0, minus 1. Now we're getting there. Now I want to get rid of that 3. What I want is I want a 1 there, a 1 there, and a 1 there, and I want a 0 there, a 0 there, and a 0 there. So, now this seems a bit strange, but I'm now going to go b minus 3 times a. If I multiply this by 3, this becomes 3. So I go b minus 3 times a. And I have to do a little bit of math in my head, but so I'm not changing the top row though. I'm not changing a. So 1, 1, minus 1, minus 1, 1, 0. That's fine. That's the same. But I'm now going b 3 minus 3 times a. So 3 minus 3 times 1 is 0. 2 minus 3 times that is 2 minus 1. And 1 minus 3 becomes positive 4. 0 minus 3 minus, that becomes positive 3. 1 minus 3 times 1, so it's going to become negative 2, and that's still going to remain 0, and I didn't touch the bottom row, so 1, 0, minus 1. Woo! Okay, so I've now got a 1 there. I've got the easiest way here is I'm just going to apply this and multiply this row by minus 1, and that turns out into a positive 1. So I'm going to go times minus 1, minus b. So basically I'm going to go minus 1 times b. So again, I haven't changed the top row. 1, 1, boom. Minus 1, 1, boom. 0 minus becomes positive 1, negative 4, negative 3, positive 2, 0, 0, 0, 1. I haven't changed the bottom row. Okay, so that's Gaussian elimination, takes it to this point here. Notice now that I've got a row of leading ones, and if we were doing an augmented matrix, that would now be finished. However, with Gauss-Jordan, I also want this one, and this one to be a 0. If I can do that, if this now becomes a 0, this is 0, and this becomes an identity matrix, and this is the inverse. So, now put the column here. Sorry. How can I do this? Well, I've got to get rid of this. I'm going to get rid of that. So I've got two choices here. I can go I'm going to get rid of this one here, this negative one here for a start. I'll just get rid of it. And the easiest way to do that is go A plus C, because if I go negative 1 plus 1, that becomes a 0. So remember, this is A, B, C. I'm going to do some more over here. So, and while I'm here, I'm going to do 2 rows at the same time. I'm going to do the same thing here. I'm going to get rid of this here. So this is going to be B plus 4 times C. Because if I do that, if I multiply that 4, that becomes 4 plus negative 4 becomes 0. So I haven't touched the top row or the top equation. That remains unchanged. Minus 1, 1, 0. I then look at this equation. I go, sorry. Oh, I am changing the top equation. Oh, sorry, my bad. Let's do that again. I am changing the top equation. Thank you for everybody that spotted that. I'm going A plus C, so that's going to be 1 plus 0 is 1. a plus 1 plus 0 is what? Still 1. But this is negative 1 plus 1 is 0. And on this side, remember what I do to this side of the equation, I must do to this side. So we have a plus c, negative 1 plus 1 is, that becomes a 0. 1 plus 0 remains a 1. And 0 plus negative 1 becomes negative 1. That's cool. Okay, that's much better. And now I'm doing equation B. B is that plus 4 times that, so 0 plus 4 times 0 is 0. 1 plus 4 times 0 is 0. Sorry, 1 plus 4 times 0 is 1. Negative 4 plus 4 times 1 is, that's 0. So now we must do the same over here as well. So we've got negative 3 plus 4 times 1 is going to be positive 1. 2 plus 4 times 0 is 0. And 0 plus 4 times that is going to be minus 4. I screwed up. It should be a 2, sorry. Because 2 plus 4 times 0. Okay, I had too many zeros in my head. So that should be 1, 2, negative 4. And the bottom row hasn't changed at all. Okay, so now I just want to turn this into a 0. And hopefully you can see by now that if I subtract this from this row, so if I go A minus B, that will become 0. So if I go, so I go, because I'm adjusting the first row, 1 minus 0 is 1, 1 minus 1 is 0, 0 minus 0 is 0, 0 minus 1 is minus 1, 1 minus 2 is minus 1, minus 1 minus minus 4 is positive 3, and then the rest of the matrix C is unchanged because 0 minus 1. So we started off here as the matrix C A equals 2, 1, 2, 3, 2, 1, 2, 1, 1. So A inverse is going to be, did that, turn that into the identity matrix. This side becomes the inverse, equals minus 1, 3, 1, 2, minus 4, 1, 0, minus 1. And the easiest way, if you want to mathematically cross-check it, we're not going to do that now. So if you want to check that this is actually the inverse, if you multiply this matrix by this matrix, you'll end up with the identity matrix. So that's only true if this is actually the inverse. So if you multiply a matrix by its inverse, you will end up with the identity. And that's a good way of cross-checking to see if you've actually done your inversion correctly.